SQA Higher Maths 2017, paper 2, question 1 had this one. It's your standard, you've got a triangle, the coordinates of B are 3, 0, C are 9, minus 2. So I'll just write these as we go. And the broken line is the perpendicular bisector of BC. Find the equation of a perpendicular bisector. So a perpendicular bisector cuts a line in half at the right angles. So I can find the midpoint using the midpoint formula and then go from there. So for part A, I'll just call this point M. M is equal to 9 plus 3 over 2 and 0 minus 2 over 2. 12 divided by 2 is 6. Minus 2 divided by 2 is minus 1. So we get our middle point, our midpoint. We now need the gradient of BC. Then use perpendicular gradients. So the gradient of BC is equal to minus 2 take away 0 over 9 take away 3. That's minus 2 over 6, which is minus a third. So therefore, the gradient of our perpendicular is equal to 3. M1 times M2 equals minus 1. And we've got a mark there for getting a gradient of BC, then our perpendicular gradient, and then finally to get our equation of a straight line, using our midpoint, y minus b, mx minus a, y plus 1 is 3x minus 6, or y equals 3x minus 18, take away 1 is minus 19 for our final mark. B says the line makes an angle, the line AB makes an angle 45 degrees with positive direction of the x-axis. Find the equation of AB. So we're going to find the gradient using tan theta and then use the point A to find the equation of the straight line. That be M equals tan of 45 degrees, which equals 1, and our point. So the point we've got is point B, which is 3, 0. So our point is 3, 0. So y minus 0 equals 1x minus 3, or y equals x take away 3. And we've got 2 marks here. Part C. Find the coordinates of the point of intersection of AB and the perpendicular bisector BC. Simultaneous equations, in other words. So we've got 2 equations, 3x minus 19 and x minus 3. Y equals 3x minus 19. Y equals x minus 3. Since they're both y equals, I can say that this side equals this side. So we get 3x minus 19 equals x minus 3. So 2x equals 19, take away 3 is 16. X is equal to 8. So we get 8 and then sub it in to get y. Well, we know that y equals x minus 3, which is 8 minus 3, which is 5. The coordinates of the point of intersection are 8, 5. And we're done there. Okay, factors and remainders, SQA Higher Maths 2017, paper 2, question 2. Show that x minus 1 is a factor of f of x, and then hence otherwise solve f of x equal to 0. So for part A, we could use synthetic division. So we get 2x cubed minus 5x squared plus 1x plus 2. And we're showing x minus 1 is a factor, which means that 1 is a root. So I'm subbing 1 in. Drop the 2 down. 2 times 1 is 2. 2 minus 5 is minus 3. Minus 3 times 1 is minus 3. Minus 3 add 1 is minus 2. Minus 2 times 1 is still minus 2. And minus 2 add 2 is 0. So since the remainder is 0, x minus 1 is a factor of f of x. And now we have to solve it equal to 0, so we can just straight away say x minus 1, that's our factor, 2x squared minus 3x minus 2 equals 0. And we need to solve that. So hopefully we can factorise the second bracket. So that would be double brackets. And this is National 5 work, so revised factorising if you need to from National 5, but you've got 2x and x. And I'm looking for 2 numbers at times to get to make 2, so that must be 2 and 1. So 2 times 2 is 4, minus 1 is 3, so it goes this way. And it's going to be 2x plus 1 and x minus 2. Just a double check. Minus 4 plus 1 is minus 3. 1 times minus 2 is minus 2. So that gives a the first bracket is x equal to 1, or 2x plus 1 equals 0, or x equals 2. Solving our middle one, we get x equal to 1, or x equals minus a half, or x equals 2, and we're done there. The intersection of lines and circles again. The line 3x intersects the circle with equation x minus 2 squared plus y minus 1 squared equals 25. Find the coordinates of the point of intersection. So if they intersect, it means we're solving them simultaneously to see these points. So y equals 3x is our first equation. And when we'll write down our circle equation, x minus 2 squared plus y minus 1 squared equals 25. So to solve these simultaneously, we use substitution. We know that y is 3x, so we'll replace the y with 3x in this equation. So we've got x minus 2 squared plus 3x minus 1 squared equals 25. Multiplying out our brackets to get a quadratic then, we've got x squared minus 4x plus 4 for the first bracket, and then we've got 3 3s is 9x squared, 3 1s is 3, double that is 6, so minus 6x plus 1. And then I'll just take away 25 and make it equal to 0 because I'm going to get a quadratic. If you're struggling with multiplying out these brackets, you can just take your time and multiply them out any way you want. So we've got x squared and 9x squared is 10x squared minus 10x. 4 plus 1 is 5 minus 25 is negative 20 equals 0. 10 is a common factor. X squared minus x minus 2. So 10, hopefully it's factorizable. 2 and 1. We want to get minus 1, so it's minus 2 plus 1 is minus 1. Minus 2 times 1 is minus 2. So x equals minus 1, or x equals 2. We've got our x point, now we need to get our y point. So when y equals 3x, at x equal to minus 1, y equals minus 3. The point is minus 1 minus 3. And for y equal to 3x, when x equals 2, y equals 6. So our point is 2, 6. There's our 2 points of contact. And we're done there. It's Great High in Maths 2017, paper 2, question 4. Express 3x squared plus 24x plus 50 in the form ax plus b squared plus c, and always completing the square. And then, given that f of x equals this, find f dash x, differentiation, and then hence otherwise, explain why the curve is strictly increasing. So let's start off with completing the square for part A. So we've got 3x squared plus 24x plus 50. So we can just take 3 out as a common factor between the first two terms to get x squared plus 8, x, and then leave the 50 where it is, and then just complete the square on that bit. So we've got 3, and then half the middle term, x plus 4 all squared, and immediately take away the 4 squared. And we've still got plus 50 on the end. So then just expanding the brackets, that's 3 times x plus 4 squared. Now 4 4s is 16. 16 times 3 is 48. So it's minus 48 plus 50. So that's 3x plus 4 squared minus 48 plus 50 is plus 2. And we're done there. Part B says, given that f of x is this, find f dash x. So part B, we know that f of x is equal to x cubed plus 12x squared plus 50x minus 11. So f dash x is 3 in front, x squared, 2 12s is 24x. 50 times x is just 50, and then minus 11 is 0, so we're done there. Question C says, hence allows to explain why the curve with equation y equals f of x is strictly increasing for all values of x. So all we need to do is check, is the derivative greater than 0 for all values of x? Well, the derivative is 3x squared plus 24x plus 50, but that's the same as 3 bracket x plus 4 squared plus 1. So we can say that the derivative is equal to 3 times x plus 4 squared plus 2. Now, we know that x plus 4 squared, if we just take that bit out, is always greater than or equal to 0 for all x. because to pick a negative number, you square it, you get a positive number, right? So therefore, we can then say, well, if that's always greater than or equal to 0, then 3 times x plus 4 squared, well, that's always greater than or equal to 0. But then if you add 2, that must be always bigger than 0 for all x, because you're adding 2. And therefore, if f of x is strictly increasing for all x. And we're done there. SQA High Maths 2017 Paper 2 Question 5 on vectors. Express P to Q in terms of IJK. So we want to go from P to Q. I can't get there directly, but do we know P to R? Yes, we do. And do we know R to Q? Yes, we do. So we can just add them together. So for part A, P to Q is equal to P to R plus R to Q. So P to R is 9, 5, 2. 9, 5, and 2. Plus R to Q is minus 12, minus 9, 3. Adding them together, 9 minus 12 is minus 3. 5 minus 9 is minus 4. And 2 plus 3 is 5. And we're done there. Now writing it in terms of IJK, that's minus 3i minus 4j plus 5k. Part B. The point S divides QR in the ratio 1 to 2. So let's look where QR is. So 1 to 2, there's 1, there's 2, clearly that's a bigger part. And it says, show that PS is equal to this. So we want to go from P to S. So we can go P to R plus 2/3 of the way along R to Q. So let me just write that down. P to S is equal to P to R plus 2/3 of the way along R to Q. So PTR was 952 plus 2/3 of minus 12 minus 9, 3. So that gives me 9, 5, and 2 plus 12 divided by 3 is 4 times 2 is 8, so minus 8. 9 divided by 3 is 3 times 2 is 6, so minus 6. 3 divided by 3 is 1, times 2 is 2. So we get 9 minus 8 is 1, 5 minus 6 is minus 1, 2 plus 2 is 4. So that equals I minus j plus 4k as required. Question 5c, hence find the size of angle QPS. So QPS, that's that one here. So we need P to Q dot P to S. And it's the size of the angle in between. Because to start with, exam paper says A dot B equals the size of A times the size of B times the cos of theta. So let's just take a note of that. A dot B, size of A, size of B, cos theta. So we need this A dot B, and we need the size of A and the size of B. Where A was just our first vector, and B is our second vector. So the size of, let's do P to Q dot P to S first. So we just times each component together. Minus 3 times 1 is minus 3, plus minus 4 times minus 1 is 4, plus 5 times 4, which is 20. So adding all that together, we get 21. So now we need the size of P to Q and the size of P to S. Size of P to Q, remember that's just like Pythagoras, so it's just the square root of minus 3 squared plus minus 4 squared plus 5 squared. Well, that's 9 plus 16 is 25, plus 25 is 50, so root 50. No need to simplify, because you're just going to use it in the formula. Only simplify at the end if you have to. Size of PTS, square root then of 1 squared plus minus 1 squared plus 4 squared. That's 1 plus 1 plus 16 is 18. 18. So that means that we can work out our cos theta now. Because our cos theta is just going to be A dot B, so this, divided by these two, which is these two. Nothing to work out, just do it, write it. So we've just got 21 over root 50 root 18. So that means that theta is the inverse cos of all that. 21 root 50 times root 18. Getting a calculator for that bit. Shift cos 21 divided by, I'll put a bracket just to be on the safe side, root 50 times root 18, close the brackets, 45.57 or 45.6 degrees to 1 decimal place. And we're done there. SB High Maths 2017, Paper 2, Question 6, Trigonometric Equations. Solve 5 sin x minus 4 equals 2 cos 2x. We've got a sine on one side and a cos on the other. Not much you can do there. You're going to have to get it all over the same side and then make it all look the same, either all sine or all cos. So let's move the 2 cos 2x to the left-hand side. So if I put it in front, it'll be minus 2 cos 2x plus 5 sin x minus 4, and that would be equal to 0. Cos 2x is a double angle, so we can use double angle formula for cos 2x. Since I want to make it look all the same, I'll make it look like sine. So start of exam paper, cos 2x is 1 minus 2 sine squared x. So I say minus 2 times 1 minus 2 sine squared x plus 5 sine x minus 4 equals 0. Don't know why I put a degree sign on there. Expand the brackets, we get minus 2 plus 4 sine squared x plus 5 sine x minus 4 equals 0. Tidying it up and getting it in the correct order. 4 sine squared x plus 5 sine x minus 4 minus 2 is minus 6. No common factor there, but usually this will be factorizable, so let's double check. So this is like 4x squared plus 5x minus 6. So double brackets, nice and big. We're going to have something sine x instead of x. And then it's a case of trial and error. It's National 5 work this, so revise National 5 factorising if you need to. But 4 sine x times 1 sine x gives me that. And then factors of 6. 4 2s are 8. 8 minus 3 is 5. So it's 2 and 3. So the outer ones, 4 2s are 8. That'll be plus 8. 3 1s are 3. Minus 3 is 5. So it's plus and minus. Take your time doing that if you have to. So you get two equations. You get 4 sine x minus 3 equals 0. Or you get sine x plus 2 equals 0. So that means that 4 sine x equals 3. And therefore sine x equals 3/4. And the other side, you get sine x equals minus 2. And therefore, we can say no solutions for that one because sine x goes up and down to a max and minimum of 1 and minus 1. So I can just say no solutions. I can even say cos the min value equals minus 1. Okay, so the other one I can solve. So the inverse sine of 3/4. Use a calculator to work that out, but make sure your calculator's in radians because that's what we're working in at the moment. If you look at the range, so that is 0.85. And then our cast diagram, sine is positive, so it's pi minus. So I do pi minus 0.85. Again, just using a calculator or type 3.14, and you get 2.29. So just to tidy this up, x equals 0.85 or x equals 2.29. And we're done. Okay, stationary points under nature, SQ High Maths 2017, Paper 2, Question 7. Find the x-coordinate of the stationary point on the curve with equation y equals 6x minus 2 root x cubed. Then find the greatest and least values of y in interval 1 is less than or equal to x and less than or equal to 9. So part A, stationary points occur when the y by dx is 0. So we need to get it ready to differentiate. So with part A, I've got y equals 6x minus 2. I've got x cubed, so the cubed comes along for a ride, but it's a square root, so it's over 2. The y by dx then, 6 minus 2 times 3 over 2, x to the half, because I take away 1 from the power, and then we can say that stationary points occur when the y by dx equals 0. So making this equal to 0, we get 6. These 2's cancel, so minus 3. X to the half equals 0. So 3x to the half equals 6. X to the half equals 2. Remember, x to the half means the square root of x equals 2. So I'm looking for, if I square both sides, I get x equals 4. And we're done there. Part B, hence determine the greatest and least values of y. So at x equal to 1, y equals 6 times 1 minus 2 times the square root of 1 cubed. 6 times 1 is 6, minus 2 equals 4. At x equal to 9, the other one, y equals 6 times 9, minus 2 times the square root of 9 cubed. 6 times 9 is 54, minus the square root of 9 is 3, so 2 times 3 cubed. 54, 3 3s are 9 times 3 is 27, 27 times 2 is 54, that gives me a big 0 is the answer at the limits. So now I need to evaluate it at x equal to 4. So at x equal to 4, we've got y equals 6 times 4, minus 2 times the square root of 4 cubed. 24 minus 2 times the square root of 4 is 2, so 2 cubed. 24, 2 cubed is 8 times 2 is 16. 24 minus 16 is 8. So then we can just state our greatest and least values. The greatest value is 8 and the least value is clearly 0. So greatest value equals 8, least value equals 0. And we're done there. SQA Higher Maths 2017, Paper 2, Question 8 on sequences. This time it has quadratics in it as part of the question. So it says sequences may be generated by the recurrence relationships of the form un plus 1 is k un minus 20 and u0 equals 5, where k is a member of the real numbers. Show that u2 equals this expression. Well, u2 is generated by u1. I've not got u1 nor got u0. So first of all, for part A, I need to find u1 because it will be k times u0 minus 20. And we know that u0 equals 5. So we can sub in that to get u1. 5 times k minus 20. And now we can find u2 because going up, u2 is just going to be ku1 minus 20, but we know that u1 is equal to 5k minus 20. So we can just sub that in. So that means that u2 is k times the whole of u1, 5k minus 20, then take away 20 on the end. That gives me 5k squared, multiplying out the bracket, minus 20k, and then we've got minus 20 on the end as required. Part B, determine the range of values for which u2 is less than u0. So part B, if u2 is less than u0, then we can just say that 5k squared minus 20k minus 20 is less than u0, which was 5. And we're just solving a quadratic inequality. So now we're moving away from sequences and moving into quadratic inequalities. So let's just do this for the sake of completeness. We've got 5k squared minus 20k, and taking the 5 over, that gives me minus 25 is less than 0. And we can examine the turning points. So if we have to examine the turning points, that is happening when 5k squared minus 20k minus 25 equals 0. Taking 5 out as a common factor, we get k squared minus 4k minus 5 equals 0. And we can factorize as much as we want to get k and k, 5 and 1. And 5, it'll be minus 5 plus 1. So we get turning points when k is equal to minus 1 or k is equal to 5. So looking at a turning point, we can then just draw a quick sketch of a graph, noting minus 1, noting 5, There's your rough graph. And we want 5k squared minus 20k minus 25 to be less than 0. So we're looking at, if I just draw this in a different colour, it's less than 0 when it's below the x-axis. So it's below the x-axis in between these 2 points. So that happens when minus 1 is less than k is less than 5. So when minus 1 is less than k, and which is less than 5, and we're done there. Dogs. Finding the relationship from a straight line. So in other words, changing the axis so that one or both become logarithmic axes, and then that makes a straight line, so we can work from there. So let's have a look at this question. Two variables x and y are connected by the equation y equals k times x to the power of n. The graph of log 2y by log 2x is shown. Find the values of k and n. So you can memorize how to do this, but I usually just start from the beginning, which is to say that y equals kx to the n. If I've got y equals kx to the n, I can log both sides. And the base is 2, so I can say that log base 2 of y equals log base 2 of kx to the n. Separating the product k and x to the n, I can say that log 2y equals, I'll write the x one first, log 2x to the n plus log 2k. So I can then write log 2y equals n comes down, log 2x plus log 2k. And that looks like now y equals mx plus c. That's like your big Y equals, that's like your mx plus c. So our gradient is equal to our n, and our c is equal to our log 2k. So if we can find the gradient, we know our n, and we can find c with where it cuts the y-axis, we know log 2k. So let's look at our graph. So for our gradient, we've got along 12 and up 3 over 12. So our gradient is 3/12. So our gradient is equal to 3 over 12, which simplifies to 1/4, and therefore n equals 1/4. Now to get our c, we know that log 2k is where it cuts the y-axis. Our graph tells us it cuts the y-axis at the number 3. So we're just solving log 2k equals 3. That means 2 to the power of 3 equals k. 2 to the power of 3 equals k, and therefore k equals 8, because 2 cubed is 8. And we're done there. Next we have maths 2017, paper 2, question 10 on equation of a circle. It says show that points A, B, and C are collinear. And then it says they're drawn inside a bigger circle, and it tells you some radiuses. You have to determine the equation of the bigger circle with centre D. So let's tackle part A first, collinearity. So for part A, we've got A is -7 -2. We've got B is 2, 1. And we've got C is 17, 6. So to show that 3 points are collinear, you just need to examine the gradients between A and B and C. And if they are the same, they are parallel, but we've got a common point, so we're collinear. So the gradients between A and B, that is 1 minus -2 over 2 minus -7. That is 3 over 9, which is a third. So we've got a gradient to A and B. Now the gradient to B and C. Well, that is 6 minus 1 on the top and 17 minus 2 on the bottom. That's 5 over 15. So that's a third. So write a little statement. The gradient to A and B is equal to the gradient to B and C. So AB and BC are parallel. But B is a common point. So A, B, C are collinear. And we're done there. Okay, let's tackle part B. It says the centres A, B, and C have radiuses √10 to ARA and RC is RA plus RB. Determine the equation of a circle with centre D. So if the first one is √10, the second one must be 2 √10 because it's double the first one. And the third one is equal to the second one, the first one, which is root 10, plus the second one, which is 2 root 10. So that gives me 3 root 10 for my final radius. So we know let's just annotate this circle. We know that A is minus 7 minus 2. Minus 7 minus 2. And we know that that is root 10. We know that B is 2, 1. And we know that this distance here is 2 root 10. That means it's the same on this side as well. And then C's point is 17.6. But we know that C is now 3 root 10 from here to here. And for us to get the equation of a circle, we need two things. We need the radius of the circle and its centre. Well, do we know the radius? Well, let's just use a different colour. This distance here is also 3 root 10. So the radius from D all the way over to here is 3 root 10 plus 3 root 10, which is 6 root 10. So our radius, if I just write it at the side of the big circle, is 6 root 10. And now to get the centre D, well, let's have a look. That's 2 root 10, and that's 3 root 10. So if we take this distance here, which is 5 root 10, D, we could say, is 2/5 of the way along. 2 plus 3 is 5. So it's 2/5 of the way up. So let's just write that down. D is 2/5 of the way up BC. So then how do we get the centre? Well, it starts at 2 and it ends up at 17. So the difference between 2 and 17 is 15. 17 minus 2 equals 15. 2/5 of 15 is 6. So if we were to draw a kind of right angle triangle here, we know that along the bottom is 15, but it has to go along 6 first and then along another 9 because it's 2/5 of the way along. So 6 plus 2 is 8. So to get our centre, we've got 8, and then going up the way. So we know that height is 5, so 2/5 of 5. That small distance in here then would be 2. So I'm starting at 1 and going up 2, so that makes it 3. So we then get the 0.83. Hopefully that makes sense. So we've now got our centre and we've now got our radius. So for part B, our centre was equal to 83 and our radius was equal to 6 root 10. So x minus a squared plus y minus b squared equals r squared, which is 6 root 10 all squared. Tidying that up, x minus a squared plus y minus 3 squared equals, well, this bit, 6 sixes is 36, root 10 squared is 10, it's 360. And we're done there. SQA Higher Maths 2017, Paper 2, Question 11, Trigonometric Identities. Part A, show that sine 2x over 2 cos x minus sine x cos squared x equals sine cubed x. So the way to deal with these is just keep it separate, start dealing with the left and start making it equal to the right hand side. You may have to manipulate the right hand side separately as well, so you get two different things equal, but in this case, probably not. So let's look at the left hand side. We've got sine 2x, we can write that as 2 sine x cos x, just using the start of the exam paper, over 2 cos x. And then we've got minus sine x cos squared x. So we can cancel the 2's and we can cancel the cos x's from here. So that leaves just sine x for this one, minus sine x times cos squared x. Sine x is a common factor in this case, so that gives me sine x bracket 1 minus cos squared x, and if you're paying attention, you'll realise that 1 minus cos squared x is also equal to sine squared x. Just check the exam paper. Sine squared plus cos squared equals 1. So that means I can say that that is sine x times sine squared x, which is equal to sine cubed x, as required. Okay, part B, hence differentiate sine 2x over 2 cos x minus sine x cos squared x between 0 and pi over 2. So if we're going to differentiate that, we can just differentiate the right-hand side because it's equal to it. So for part B, d by dx of the left-hand side equals d by dx of what we just found out, sine cubed x. Now, sine cubed x, remember, means the sine of x squared. So it's easier to write it like that to see exactly what you're doing. So if I just write sine of x, that's to be cubed. So I have to differentiate sine x all cubed. So that's the chain rule. So the chain rule says I take the power down to the front, I leave the function alone, so it's sine x. And then I take 1 away from the power, so that's squared. But then I need to differentiate the inner function, which is sine x. Check the start of the exam paper, sine x goes to cos x, so times by cos x. Tidying that up, that's 3 sine squared x cos x, and we're done there.